So, have you ever felt like losing weight and actually keeping it off is just this constant uphill battle? Well, what if I told you it has way less to do with willpower than you think? Today, we're diving deep into the powerful, ancient system inside your brain that's really in charge of your body weight, and we'll look at how a whole new generation of drugs is tapping directly into that system.
This quote right here, it just nails it. It perfectly captures the core of the issue. What it means is that our bodies, our biology, are running on software that was designed for a completely different world. And it's that mismatch between our ancient genes and our modern environment that really sets the stage for everything we're about to talk about.
All right, let's just get this out of the way first. We're going to tackle the single biggest misconception about weight right from the start. For decades, the whole conversation has been about one thing: willpower, self-control. But you know what? The science tells a completely different and way more fascinating story.
I mean, really think about that for a second. Does it seem plausible that millions and millions of people all across the globe just woke up one day in the 1970s and collectively decided to lose their self-control? Of course not. The evidence tells us something else is going on. The real answer is much deeper, and it's inside our own biology.
And this is a huge shift in thinking. The scientific community has really come to a consensus. Obesity isn't a character flaw. It's a complex medical condition, a neurobiological disorder. Its roots are planted firmly in the brain and in the intricate wiring that's supposed to control our energy balance.
So just how big is that biological component? Well, get this. When scientists study identical twins, they estimate that up to 70% of the variation in our BMI is inherited. 70%. That means for many of us, our genes make us way more susceptible to gaining weight in our modern world than others.
Okay, so if this is a brain issue, where exactly is all this action happening? Well, let's zoom in and meet the master regulator, the part of your brain that acts like a thermostat for your body's energy.
Now, the system this command center is managing is called energy homeostasis. You can just think of it as your body's automatic accounting system. It's constantly trying to balance the calories coming in with the energy going out, all to keep your weight stable. And this isn't something you think about. It's a deep, primal survival mechanism that's always running in the background.
And the headquarters for this whole operation? It's a tiny but incredibly powerful part of your brain called the hypothalamus. It's tucked away right at the base of the brain, and it's the main hub processing all the signals about your energy status. And inside this little command center, there's this incredible drama playing out 24/7. You've got two opposing groups of brain cells, or neurons, and they are in a constant tug-of-war for control. Let's meet the two teams.
So on one side, you've got your hunger neurons, the AGRP neurons. When these guys are firing, they are screaming one simple message: go eat. They get switched on when your body senses it's low on energy. Then, on the other side, you have the satiety neurons, the POMC neurons. Their message is just as clear: stop eating. They get activated when you're full. The balance between these two powerful forces is what dictates if you feel hungry or satisfied.
So that begs the question, right? How does this command center, tucked away in your head, actually know what's going on in your stomach or your fat tissue? It doesn't have eyes. Well, it relies on a really sophisticated messaging system.
Yeah, your brain isn't just guessing. It's getting a constant, nonstop flood of real-time text messages from all over your body. And these messages are hormones. They carry critical updates from your gut, your stomach, your fat cells, straight to the hypothalamus.
Let's look at three of the big ones. First, there's leptin. It comes from your fat tissue, and it's like your long-term fuel gauge, telling your brain, hey, we've got plenty of energy stored. Then you've got ghrelin, the famous hunger hormone from your stomach. It's a short-term signal that basically screams, the tank is empty. And then there's GLP-1. This one comes from your gut after you eat, and it sends the message, okay, food has arrived, mission accomplished, you can stop eating now.
And that last hormone, GLP-1, brings us to one of the biggest medical breakthroughs of our time. Because scientists looked at this natural messaging system and had a brilliant idea. What if we could hijack it?
See, these new weight loss drugs you hear so much about, they aren't some magic potion that just melts away fat. They're much smarter than that. They are powerful, sophisticated mimics of your body's own hormones. They don't introduce anything foreign. They just amplify the natural signals your body is already using.
And the results of this approach? They've been absolutely staggering. In clinical trials, we're seeing average weight loss of nearly 15%, even close to 18%, levels that were pretty much unheard of with medication alone. Compare that to about 2% for people taking a placebo.
It's a game changer.
So how do they actually pull this off? It's a pretty elegant mechanism. So step 1, you eat, and your gut releases its natural GLP-1. Step 2, that hormone travels to the brain's command center. Step 3, it hits those stop eating neurons, telling you you're full. But here's the catch. Natural GLP-1 only lasts for a few minutes. So step 4, these new drugs act like a superpowered, long-lasting version of your own GLP-1.
So really, all they're doing is taking that quiet, I'm full, whisper from your gut and turning the volume way, way up. They're making it a loud, clear, and sustained announcement that the brain simply cannot ignore. And that powerful signal is what reduces appetite and leads people to eat less.
This is all incredible, for sure, but it also opens up the next big question. If we can manipulate the signals going to the brain, is it possible to create lasting change in the brain's wiring itself? This is the next frontier. And the key idea here is something called neuroplasticity. It's just a fancy word for the brain's amazing ability to change and rewire itself based on experiences. The connections in our brain aren't set in stone. They can get stronger, weaker, or even form totally new paths over time.
But here's the current challenge. While these drugs are fantastic at changing the signals the brain is hearing, it seems that when the drug is stopped, the underlying wiring often hasn't permanently changed. The brain's old patterns can come roaring back, and with them, the powerful drive to regain the weight.
Which leaves us with this final, massive question. We've figured out how to temporarily hack the system, but can we take that knowledge and figure out how to permanently rewire the system for long-term health? That's the challenge, but it's also the incredible promise for the future of medicine.